Episode 113, and in this episode we're going to show you how to get started with programming the FPGA on your Matrix device, whether that be the Matrix Voice or the Matrix Creator. So a little bit of background, both devices have an FPGA. It's a Xilinx Spartan-6 FPGA. The Matrix Creator has it right on the back, so if we get the Creator, so you can see here, right back here is the Spartan-6 FPGA. It's the lowest tier one, and then the Matrix Voice has an FPGA on the front, which is like the second tier Spartan-6 FPGA, so a little bit more powerful. And basically in the guide, this is a guide that we'll be posting on Hackster tomorrow, and Samarine created it.
With the help of your other hard-earned me.
Yeah. And she'll be showing you how to go through like setting up the environment. You can set this up like on Windows, Linux, Mac, as well as how to start programming it and some cool little examples of like the cool demos that you could do to start out. So yeah, with that, I'll take it off to Samarine.
Alright, so for programming the Spartan-6 FPGAs, I'm going to switch over to my computer. We basically use the Xilinx ISE Design Suite, so I'll like show you all real quick. So this is the guide. It's on GitHub right now. Forgive typos, I haven't like thoroughly proofread everything yet, but I did follow it and it works, so that's good. So you go to the Xilinx website, so I'll just show you like what you would be using, and what you use is the ISE Design Suite, which is basically like you can use it to program the FPGA or like compile code on the FPGA. So that's what we use it for. We don't actually use like the UI for it. For us, it just kind of has to be running in the background, and when we like when we're compiling the FPGA code. So this is a guide. So you can, there are like installation instructions for the Xilinx ISE Design Suite for Linux, Windows, and Mac. Linux, you know, it's like the longest. It's got lots of steps. But for Windows, it's super easy. You just like install a zip file, extract it, run a setup script, and it kind of walks you through the installation. Xilinx doesn't officially support Mac installation, but I basically realized that since for Windows you do it on a VM, that you could basically do it on a Mac as well. So you kind of, I kind of have steps where you download the Windows zip file and then like extract and set up the VM for your Mac on VirtualBox. So it's also like pretty straightforward. I won't go through step by step the installation process because it's you know, it's pretty straightforward. There's steps here. They're like step by step, like what you have to put in the command lines. If you're in Linux, if you're in Windows, it's literally just like next, 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 create kind of a thing. And the only thing you'd have to keep in mind is after you download it, you have to like get the license, and that's like free if you make an account on you know, the Xilinx website, and there's like there are direct links that will take you to a login page. You create an account, you know, it'll look like this, and you just like put in your like address, things like that. They just do some verification, and then you can download a license file. So, and the ISE license file is free of charge, so that's super nice. So I guess we can go straight into sort of the simple example I had. It's like, honestly, it doesn't have too much of a utility in a sense, because basically what we're doing in this example is connecting a wire from the Raspberry Pi like GPIO directly to like a Matrix Voice GPIO, so exposing the Raspberry Pi GPIO, because if you don't already know, the Matrix Voice GPIO basically has its own like framework. Like in the FPGA there's codes so that like the GPIOs of the Matrix Voice are their own. They can be programmed using our libraries, like not directly through the Raspberry Pi GPIOs. So the reason I did this is kind of just, I'm super new to FPGA programming myself, and the point was just kind of to see if it works, how it works, you know, like the steps to like edit the code, compile the code, and then upload it to your Raspberry Pi, and how to flash the FPGA, like how to flash the FPGA on your Matrix device. So Let's see. We can go through. I think it's like super important. So a couple of things before I get into it. There are a couple of warnings in the sense that like you kind of have to be deliberate and kind of know what you're doing because the FPGA is like wired hardware. So, you know, there could be a chance you can disable your device if you don't know what you're doing at all. But, you know, I mean, I'm also very new to this, but like I didn't, you know, do anything bad. So that's a pro.
One thing for a second. Apparently, the fan on our computer sounds like running water.
Wow, that's
it's
never
that
happened
loud.
before.
Yeah, so here, let's move the mic
Sounds
just
like
a little bit
Okay.
to see if that helps. Okay, let me twist this
Right,
around.
So hopefully we won't hear running water anymore.
Okay, hopefully that's better. But yeah,
Was
continue.
everything like audible though?
Yeah, it's
Okay,
audible. It's
okay.
just it sounded
Okay,
like there
yeah.
was running water
Apologies.
in the background.
Okay, that cool. All right.
That was good though.
All right, awesome. So just making sure everything is okay in terms of settings, but everything looks okay. That's pretty normal, right? Like it's usually a
Yeah, that's fine.
Okay. All right, awesome. So yeah, beware. You need to be like a little bit deliberate and intentional about the code that you're you know, writing, and then also that the open source part of the FPGA code for Matrix devices does not have the digital signal processing of the mics, because like that we're, you know, still thinking about like how to maybe potentially like have people like reflash their FPGA but still have the DSP, but that like intellectual property essentially hasn't been exposed yet. So when you know, download, like clone the repositories of the Matrix Voice FPGA code, or Matrix Creator FPGA code, just keep in mind that your mics won't work when, you know, you have your own FPGA code on there. But if you're completely pro and have your own DSP, then go you know?
Yeah. and as Samreen said, we're looking into right now how to bundle the DSP for the microphones within the FPGA code in a way that it's still like you're able to flash the FPGA with your own stuff added to it, but the IP for the DSPs are still contained and encrypted.
Mm-hmm.
Just because like that's a difficult thing to do. So yeah, exactly.
So we're gonna go right into the example now. I don't know why I'm scrolling when I specifically put these links here. Okay, so the first thing, I feel like it's important to understand how the GPIOs on the Matrix Voice are laid out. So this is a nice graphic from our documentation where, so these are the expansion GPIOs on your Matrix Voice right here. And you can see in this diagram the connections it has. So you can see all of the like DF pins essentially are connected to, or at least connected to the FPGA, like physically. And then, so for this example, I'm going to like just use DF15, just picked it arbitrarily. You could try something else. It's connected to FPGA pin R2. That's important to know because you're going to have to change that in the code, because currently like that GPIO pin is coded to do something else. And then if you look at the Raspberry Pi GPIO connections to the Matrix Voice, so like where it connects over here, this is a big diagram. It's at first like it might seem like a lot to take in, but it's actually super nice because so this column on like each side has like the Raspberry Pi pins, and then the functions in the Raspberry Pi, and then the pin on the Matrix Voice that it goes to, and then the function on the Matrix Voice. So it's super nice. So as you can see here, GPIO 16, that's just the one I'm picking for this guide, is connected, like is basically connected to the FPGA P8. That's just like the pin on the FPGA that's connected to, and it's not really like doing anything, like it doesn't have a function right now, which is good. So like there's not going to be a lot of like code I'm going to have to mess with to expose that the Raspberry Pi GPIO through the Matrix Voices GPIO. So that's what we're going to use. So you want to start with, and that part like isn't here because it assumes you've already cloned the Matrix Voice. So we're going to the Matrix Voice repo, So I'm going to clone it and basically start editing the files. So I'm going to make a reader guide, and then just clone it in here. Okay, cool. So this is the Matrix Voice GitHub repo that has the Matrix Voice GPIO code. As you can see, the .v are Verilog files, which is like a hardware description language. It's hardware descriptive, hardware description, a hardware language basically. And let's see. So you go here, Command V, cloning into it, awesome. So now we have it here. So if you don't have Git, you can install Git, and then you should be able to clone it. So then we go to Matrix Voice FPGA and Voice Core. So as you see here, Voice Core is what has like the main files. What I'm gonna do is I'm gonna open this in VS Code, Visual Studio Code. That's like what I generally like to use, because it's just a very like nice like environment to code in. Visual Studio Code. Okay. So file. Let's see. Open add folder to workspace. And I think it should just be in guide, Matrix Voice FPGA. Cool. So added that folder here. So as you see, it shows up really nicely. So Voice Core, that's basically the main folder with all of the like kind of overarching Matrix Voice Verilog files. And then RTL has all like kind of like has broken out, like it has the Everloop Verilog files, it has the digital to analog converter Verilog files. There's a lot going on. And it's the GPIO Verilog files. So so this example is super simple. It's like just a couple of lines of code, just to kind of show that how it works and how to compile it. So we're going to change. So we're going to go to voice.ucf. So this is basically from what I understand. Interesting. I thought I had the extension for it. The color coding isn't great. Let's see. UCF. Install. Okay. Oops. Voice.ucf. Okay. I think if I restart it, it might save. Guide workspace. The color coding will be better. Visual Studio Code. Come on, file, open, reset, guide workspace. Okay. Voice Core, Voice UCF. Okay, there we go. So it looks nicer, it's easier to read. Okay, so what we're gonna do is, so we found earlier that R2 is what so as you can see, pin 15 is connected to R2. This is the Matrix Voice GPIO pin. So all we're gonna do is just Command F R2. And as you can see, like GPIO 15 is connected to R2. Great, so I'm actually gonna rename it because I'm gonna do something different with it than what's already done there. Because right now it's the like Matrix Voice GPIO like implementation is happening there. So instead of that, I'm going to say, okay, R2 is connected to GPIO_I_15. I'm just renaming this so that I can do something else with it than what's already said there. And then P8 is what Raspberry Pi GPIO 16 is connected to. So I'm just going to Command F P8. And you see that this is already defined here, but it's commented out. So I'm just going to uncomment it because I'm now going to use it. And I'll rename it to _R Pi, just so that like I know that this is the Raspberry Pi's GPIO. So Command S save. Next, Control F to find FPGA pin P8. Okay, we already did that. Okay, so the next thing is in the system.v file, which is like one of the Verilog files that has like kind of the overall system. This stuff should have already been installed, but for some reason it wasn't, but it's okay. System.v file. I'm just gonna reopen this again so that it's colored. Sorry about that. Visual Studio Code. File, OpenWorks, Open Recent, and Workspace. Okay, awesome. So, okay, cool. So system.v. So you see there's this like parameter here called GPIO underscore width. So this is saying like how many GPIO pins there are, and this is matrix voice GPIO pins, and there are 16. But because we're doing something else with one of them, I'm going to make this number 15. And I'm going to comment it so that I remember that I did that. So change. And then we have to basically, like, everywhere GPIO width is defined as 16, you have to change it to 15. Because with the 15th pin, like, 0 to 14 is 15 pins, but with the 16th pin, we're doing something else. So the other place that, like, GPIO width is, like, mentioned is in RTL, WB underscore GPIO, and then mux underscore IO.v. So here it's 16, we're going to make it 15 again. Change. So Command S, awesome. So now that we've done that, literally all we have to do is add like 3 lines of code and like we're ready to compile, because you know what we're doing is really simple. So in system.v, this is where all the parameters are defined, like so what's input, what's output, things like that in this section. So what we're gonna do is we're just gonna like add this, which is basically saying that in-out means it's like input and output, so it's a bidirectional pin. So you're saying that the GPIO pin 16 on the Raspberry Pi can be input or an output, and so can the GPIO number 15 on the matrix voice, which is like the exposed ones on the top. So that's all it's saying. And then we go back to the guide, and then to make that physical, like, quote-unquote wire between the two, so just like connecting the two, we literally have like one line, and I'm going to put it like right here after all of the assigns. So, and that's just assign GPI underscore IO15, so the matrix voice GPIO, to the Raspberry Pi's GPIO. And that's it. So like once we save that, all we have to do is compile it. So since I'm on a Mac, for me to compile it, I have to go to VirtualBox and open up my ISE VirtualBox like tool. So it's a Linux like machine with the Xilinx ISE already installed on it. So it's starting up, and once it starts up, I'll tell you all how you can transfer what you've already coded to the host or to the virtual machine, so that you can then compile it in your virtual machine. There's actually a shared folder between the two machines, so that's how you sort of transfer, so you can like edit stuff on the Mac or on your computer and then still access it for compilation on the virtual machine. So that's super nice. Actually, since I already know what the shared folder is, I think I'm gonna start copy pasting things. So let's see here, where was it? Drive, users, so we have guide. So this is basically what I would be copy pasting. Let's see. I just wanted to make sure I saved everything. Looks like I did. So we're gonna go back to Finder. I'm gonna copy this and then paste it in the shared folder, which honestly I don't remember the exact directory, but I can find out. So shared Xilinx, so that's where this is going. All of the shared like folders that we have. So you can basically find out what the shared folder file path is on your computer by going to shared folder settings. So let's see, we have basically just went to the Finder and copy pasted basically copy pasted the folder where we had just modified the code into this shared folder path, and then it showed up in the virtual machine. So now to like basically compile the program, you have to double click on Project Navigator, which starts up the Xilinx ISE Design Suite. And then I'm going to start another terminal session and TNT. Oh, nope, that's not what I want to do. So what I usually do is I go to matrix voice -FPGA, voice core, and then this is where the make file is, and so that's where you have to make it. So if you right click and do open in terminal, it opens up like exactly at that file path, and then all you have to do is run make. And fingers crossed that I didn't forget anything code-wise, but it takes maybe like 2-3 minutes to compile, not that long, but basically at the end of compilation we should have a file called system.bit that appears over here, and that is what we're going to then transfer to our Raspberry Pi and then reflash the FPGA. So there's going to be a bunch of warnings, don't worry about that. As long as there aren't any errors, you should be good. So what we're going to do next, I'll just start giving you a preview. We're going to, so this is the Raspberry Pi. I've already SSH'd into it, and we're basically going to use CyberDuck, which I've also already SSH'd into, to put the system.bit file that gets created from the compilation process into the home Pi directory, because through CyberDuck at least, you can't upload a file with sudo essentially. So oh no, there's an error with the license. Interesting, I had already done that, but I can do this real quick. So you go to help, manage license, and then you basically have to load the license. And this is a step that I have elsewhere in the guide as well. So I don't remember where I had downloaded the license, but let's see, back, where shared Xilinx templates. Interesting that the license file disappeared. Let me see, is it, okay, so search Xilinx.lic. Interesting, it's not. Okay, so this basically I'm going to copy it into the shared folder, because that's where I can access the license through so VirtualBox VM. So this is the part that you essentially missed when we just shared Xilinx. That's the folder that's shared. So I'm going to copy the license file in there. And basically it's going to show up here if I refresh it. There we go. So all I have to do, I'm going to actually move this license file into the desktop, and then I'm going to go to help, manage license, and go to load license, and then go to desktop, and then click the license file. And then do you wish to overwrite? I don't know why it, anyway. Okay, so technically it should make again. Let's see if it created the bit file. It didn't. So make. So the problem was encountered. Yeah, so I had this problem earlier and I did this license thingy. I don't know why it asked for it again, but if that happens, this is essentially on Mac. This is essentially what you would do. On Windows, you shouldn't have this problem because the license is kind of already like integrated through their like setup guide. They don't, since they don't officially support Mac, and this is like I did a little bit of like back and forth with loading the license. It's a bit different. But yeah, so on CyberDuck, we're essentially going to upload the system.bit file onto here and then move it to where it needs to be to flash the FPGA. And we're going to use the docs. There is like a super nice flashing guide that Boris, somebody who used to work here, wrote. So I'm just going to follow that for flashing it. So let's see. Follow the instructions here to flash system.bit FPGA. I'm going to open that up. Okay, so this is for the voice. All of this stuff I already did, but I could do again to show you. Let's check on that. So while this happens, while this compiles, I can kind of, to move ahead, like even though I've already done these steps, probably do them again. I don't know, do you think it's worth it? Like I've done like the curl, blah blah blah, sudo update, upgrade, and then install and the reboot. So I'll start from here. Like, do you think there's like merit in showing that again? Even?
Not really. I mean, that's all basic stuff.
Yeah,
it's just setting up our repositories there, updating it, upgrading it, installing our like initialization libraries, which is how the FPGA gets flashed in the first place, and then rebooting it so it all gets like set.
Yeah.
So pretty simple. And there isn't really any steps you have to do. At most, you may have to press Y. It may ask you to, like, if you want to continue doing this, so you have to press Y, and that's it.
Yeah. So, no fear, even if this takes too long to compile, I have an already compiled one as well, but it probably won't take too much longer, maybe like a minute or two. Sometimes it varies, but usually it's done in like 5 minutes. Yeah. I mean, the thing is, like, I'll say compile, like, I'll say make, and then do other stuff. So I never really like sat there and watched it, which is why
Carlos would really hate like a 5-minute compile time.
Oh yeah, no, he would hate it.
He's been working lately on making a new library for us in Python. And for that library, because he's having to work directly with HAL and C++, he has to make and compile things, and the like 20 seconds it takes to compile things kills him.
Yeah.
He's used to JavaScript where it's just instant. I mean, you just save it and run it. You don't need to compile.
Yeah. Seems like it's almost done. Okay. Well, let's see. So we're going to essentially the .bit file that it produces. We're gonna put it into the home/Pi repository. We're gonna, we can actually do this part right now. Back up the stock system voice.bit file. So that's the file that like Matrix create, like, Matrix in it, essentially like the initialization flashes to the FPGA. So we should back it up. So if you want to restore that, you have the original code with the DSP and everything. So, oh yay, bitstream complete. System.bit file here. Woo! I like honestly had like a bad feeling because you never know. Okay, so this is where we will now back up the old file. So, this basically means it worked. And then let's go here. Copy your like system.bit file and FPGA bitstream file to block folder. Okay, so before we do that, we are going to upload this file into why do I keep closing this? Okay, so I'm gonna take the bit file from the shared folder that we have, blah 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 blah, and if I go here, voice core, you can see the system.bit file has appeared. Woohoo! So I'm uploading this through CyberDuck. Cancel. Okay, there we go. So it has appeared in our home Pi, so we should be able to see it. LS. Amazing. So I'm going to paste it even though it's going to give me an error because there's no such thing as path to file right now. But I will change this to home/pi/system.bit. And so this is basically copying the file from the home Pi folder into user sharing matrix labs, matrix devices, blob, and then and then putting it into system underscore, like basically renaming it essentially as system_voice.bit because that's the file name that gets flashed. Alright, so now that we just did this part, copy your built bit file to the blob folder, which is where all the compiling happens, and then we flash the FPGA. So before I do that step, I'm actually going to CD into the place so that I can see everything. So share matrix, matrix, what did I do wrong? Matrix labs. Interesting. Usually.
Well, you put LSBS.
Where? Oh. Okay.
Yeah.
Interesting, but usually it like figures it out. Anyway.
Oh, you didn't do a slash in front of user.
Ah, thank you.
No
yes. Okay. Cool. Matrix. Okay, nice. Blob. Okay. So this is where the famous FPGA files exist. So now we're going to reset the FPGA. Copy that. Honestly, I'm not too sure what these are doing. It just looks like they're kind of, like Echo usually is just like kind of printing things, right? Not entirely sure, but the XC3 SPROG program basically flashes the SPI bootloader onto FPGA, necessary to do blah, blah, blah. Okay, so the reason it's saying that is because it says blob/bscan, so if I just like CD out of there and then do it, it'll work because it's going into the blob folder. So it'll tell you like a DNA is blah, that's a good thing. Flash the SPI flash, command tab, command V, and at the end of it, it should basically say, not really, that's not what I want to do, but it still works. Okay. Cool. So yeah, verify success. Awesome. It tells you it should do that. Reset the FPGA again. Oop. Copy. Command V. And then basically this is, so there's this file, if I go ls here, there's a file called voice.version. And this is basically saying that you need to sort of create your own, so that like you can, like you don't mess with what already exists, and updates the matrix creator init package. Interesting. Okay, so then you have to kind of make sure the matrix creator init package doesn't update, because if it does, then the correct like file, basically the changes you've made will be lost essentially. And then sudo power off, and basically wait until the green LED on your Raspberry Pi blinks 10 times, then unplug the power cable from your Raspberry Pi. What I usually do, I just give it a couple of seconds and then I unplug and replug it. And so then also there's also steps for restoring your original firmware. So if you like really think you messed up, there's steps that you can like restore it to how it used to be old. That's why you backed up the file in the first place. So you should be good. So now we're actually like basically near the end of the guide. Basically I will unplug it now. Oh, this isn't the one. Unplug it, plug it back in, and then SSH into it. So
another thing to note is if you like messed up and didn't get it working properly and you didn't back it up, you can always just reflash the SD card and
yes,
it'll install everything again and it'll work. And anything that you're doing, well, you could technically do something on the FPGA that could physically break the hardware, but if you're not being too adventurous and you're careful, then for the most part anything that you do on it won't be a hardware breaking change.
Right. So now to just kind of show you that it worked, which I'm just gonna go to another screen where the little one is of the table where everything is set up. So what you should be looking at is the LED right here. I can show you a more close-up version. I don't know why it's like autofocusing. Interesting. Yeah.
Autofocus camera.
So I can show you a more a more close-up version, like once we have it working. So if you look at the terminal, through the terminal you can actually like control the Raspberry Pi's GPIO. GPIO is using like wiring Pi essentially, like the GPIO utility. And this is like the website where it tells you how you can use it. So basically, if I do GPIO read all, I'm gonna make this a little bigger because it's so big here. BCM pin is the one that's listed here, GPIO 16, so 16. And then like wiring Pi kind of calls it something different, which is kind of annoying. So that's why like GPIO read all is nice, because we're using the BCM reading for FPGA coding, but in the terminal you would use pin 27 to change things. So right now, if I do GPIO mode 27 out, so right now you can see pin 16, which is 27, is an input. But if I do that and then do GPIO read all again, it's now an output. Because like what I want to show you guys is that I can like make an LED turn on. So you know that's an output. And then all we'd have to do is do GPIO write 27, and then I'm just gonna make it 1, and the LED is on. I don't know if you all can see, but also I can show you the voltage reading.
Yeah, I can see it.
Okay, so there's the voltage is like about 3.3, and then if I make it 0, it's off and on and off. So while this isn't like while this isn't like, you know, the most useful program to have, since like the Matrix Voice GPIO like through our libraries is like nice to program anyway, you could do like, it's just to kind of show you like the process of how you clone the repo, what files you like would edit, and then how to compile it. And you can do, you know, like lots of other like cool things with it. Like there was a Xilinx like webinar recently.
Oh yeah, yesterday actually.
Yeah, so like that was like for showing you how to put like the Cortex M1 and M3 Xilinx FPGAs, and
yeah.
So like, you know, you could do something cool like that.
And we're gonna try to see if we can do that ourselves. That way we could have 2 Cortex M3 microcontrollers on the creator.
So, you know, just a little example. I think that's all I had to show. Were you
gonna show how to port a Pi GPIO out through the expansion?
Oh, you mean like in? I actually like never tried that. But
okay,
I
well,
guess,
so
like, we would have to connect something.
Yeah. So, well, we could just say, so like one of the useful things you could do is, since the Matrix Creator and Matrix Voice both use, well, they like the connector uses all the GPIO ports. Something you could do is route one of the expansion GPIOs on the Matrix Voice or Matrix Creator to a pin on the Raspberry Pi that's not already being used by the Matrix Creator or Matrix
that's
Voice.
What this is doing.
Well, yeah, but to like I2C, like I2C or
yeah,
something.
Yeah, you could
this
do
is
it
this is doing the
what this is doing. It's connecting Raspberry Pi's pin 16 to basically the Matrix Voice's pin 15. Yeah.
I was obviously in my computer for most of this.
Yeah, but so that's why this is working, because normally this wouldn't work, because this is a Raspberry Pi's GPIO being toggled.
I see.
And it's now straight from the Matrix Creators or Matrix Voice's GPIO.
Okay, well now I obviously was shown to not have been paying attention.
Oh, I thought you were talking about it being an input, but like it's a bidirectional, so you could also like have an input. Yeah.
Okay.
But what he's
a cool use case. That is what I was getting to
Yeah.
without the other stuff, but is like let's say you want to use like the I2C of the Raspberry Pi. You can do all of this for the I2C pin on the Raspberry Pi. That way you can then connect other things to the Matrix Voice and just have it natively communicate with the Pi.
Yeah, I definitely want to try that and then test it with an I2C device.
Yeah.
See if it works, or how it works. But yeah, so there's definitely, like, even with simply, like, connecting wires, like, you can do cool things, like, expose I2C, like, on the Matrix Voice. Matrix Creator already has, like, SDA and SDL, but not from the Raspberry Pi, from the ESP32. But, you know, like, yeah, you can, like, even with connecting wires, lots of cool things you could do. Just, like, lots of, like, FPGA opens up, like, so many things, like, I honestly can't even fathom.
It's crazy.
Yeah.
The amount of things you can do with it. Yeah, it's a lot. And hopefully soon we'll be able to get the DSPs modularized so that you can edit the FPGA and still have our DSP running for the microphones.
Yeah.
Yeah. Okay, so is there anything else left in the guide?
Guide-wise, we are done. Like, what announcements? Do you want to go back to the front camera?
Yeah, we can go back to the front camera.
Okay.
Yeah, let's try to
physical front
reposition
camera.
the front camera.
Okay, yeah, that was a good repositioning.
Wow, that was cool. Here, let's make it a little higher. Wee bit higher.
All right.
Cool. Okay. Well, actually, we want to make it full screen.
Oh, it's not full screen?
Yeah, no. You see the
yeah. Yes, okay.
Okay,
hello.
cool. Hi. Cool, yeah, no, I think that was actually really cool. Like, I mean, the little parts that I was paying attention, I have no idea any FPGA things. This was the first time I even got a glimpse of FPGA code. And I was trying to figure out what was wrong with the stream with our team, so yeah. But no, I think it's really cool. We'll be releasing the Hackster guide tomorrow. So we'll post that in the link in the description for the live stream. So if you're watching this after the fact, you can see it there. Yeah, it's really good. So announcements-wise, guess a couple things. I mean, one thing, so last week we interviewed Alessandro, who's like a developer advocate for ARM. And we talked about this live stream that ARM did yesterday with Xilinx of how to set up the M1 and M3 on an FPGA, on a Xilinx FPGA. So that's something you can go check out.
We'll put the link in our, the link for that in our
in the description.
Well.
Yeah. Additionally, we are currently working on doing a cool contest with Snips on Hackster, Snips and ARM on Hackster. So stay tuned for more information on that. We'll be doing it sometime in April, and we'll be releasing little teaser hints here and there. So watch out for that. And then the Matrix kits. So we, of course, we've been talking about these kits that we've been selling. It's basically a nice box with a Matrix Creator Matrix Voice in it, connected to a Raspberry Pi, an SD card pre-flashed with Raspbian and all of our libraries, and a power supply. So all you have to do is get it, plug it in, and it works. Of course, you have to put the Wi-Fi and everything, but it works, and it's a really cool way of quickly starting out with our devices and, you know, further reducing the barrier to entry. You can see it on the screen here, and you can go to our website, matrix.one/educators, to check it out, or our store.matrix.one, and you can see them there. Yeah. What else?
Do you want to talk about Matrix Lite more at all, or?
Yeah, why not?
Yeah.
Well,
do we want to call Carlos over to talk about it?
Yeah, sure. Here, let's call Carlos.
Yeah. So Carlos has been working on Matrix Lite for you all, and he will come and tell you all about it.
Now, hi. Can we pull up the web browser?
Yeah. So here we can do this, and then you can take the chair. Yeah.
Hop on here real quick.
Musical chairs.
So, are they saying, what are they saying right now? Okay.
Yeah.
Let's see that.
This is what they're like.
Okay, got it. Okay, so let me just go over to our GitHub really quick. Or actually, our documentation should have this. I think it was docs.matrix.one. So, as you know, we currently have two layers. We have Matrix Core and Matrix HAL. And we've also added, and Matrix OS. And we're adding a fourth layer called Matrix Lite, which is currently in development. And so far we have support for JavaScript, which if you go to our documentation, the first layer you'll see will point you to it. And right now it's just a GitHub repo, but all the examples you need are in here. So setting LEDs is just one line for the whole Everloop array. This works for Matrix Voice and Matrix Creator. You have sensors, GPIO, also a microphone example using ALSA, and all the steps you need to even compile it. So the way this layer works is that it's a wrapper around Matrix HAL, so it directly interfaces with the C++. And for the future, we're also adding support for Python, which is currently in development as well. This one is earlier on than JavaScript, so it's still bare bones, but you can still play around with what's there. Just if any Python enthusiasts want to try this as an alternative. Hopefully in the coming month or so should be more fleshed out, and proper library hopefully uploaded on pip. Ideally pip 3, because this is more for Python 3.
Yeah. And basically what these layers are is it's a simpler way of programming your Matrix device. We have Matrix HAL, which is all in C++, and if you don't know C++, that can be a little intimidating, and the jargon there can be difficult to work around. We have Matrix Core, which is in JavaScript, Python, Go, and can be further languages can be supported with that thanks to Google's protocol buffers. But that basically runs a local server on the device, which is great if you want to do like cross-device communication or things in your network, or a variety of other things. So what we're doing with Matrix Lite is we're making a simple layer in JavaScript and Python and a couple other languages later on that is super straightforward, based off of HAL, so it's super quick, and there's no like 0MQ or protocol buffers that you have to deal with. So it's super light. And just allows you to just quickly start using our libraries or devices and get on with doing whatever it is you want to do. So Carlos has been the one mainly, 100% working on this. We have the JavaScript one, of course, like he mentioned. It's mostly done. The Python one that he's currently working on. So go test it out. Let us know in our community.matrix.one, if there's like any bugs, any features you'd like added. Anything. I mean, we're like currently working on this, and it's all just to make it easier for you. So,
and on a side note, potentially, the way we're working for the JavaScript version of this, we're making a Node add-on which directly calls C++. But for Python, we're using Swig. So potentially with Swig, you can compile for other languages. I think they have support for C#, Java, and a few others. We're only doing it for Python right now, but if you know Swig and you want to experiment for your language, we have a repo called Matrix HAL Swig. You could check it out and see what we have in development. We have a roadmap of what we're checkmarking for any feature requests or issues. Feel free to post anything in the Issues tab, and that should be about it.
Yeah, awesome. Yeah. Thank you, Carlos.
Cool. All right. So let's wrap it up.
Yeah.
Okay. So I guess let's wrap it up here.
So can you move and click? Yeah.
So be there, front camera, all of your friends in the screen, and so that was. So we just went over our guide. We went over Carlos's new library layer, and went over some announcements. Keep Matrix kits in mind. They're super nice to kind of plug and play with, and yeah, that's about it. Does anybody have anything to add?
No, I think that's it. Again, if you have any questions, concerns, suggestions for our new library layer, languages you want added, anything, go to our community.matrix.one. Of course, follow us on Twitter, Matrix_creator, on Facebook, Matrix Creator. And with that, I guess that's a wrap.
All right.
Thanks, guys, for watching.
Bye.
Bye. Okay.